So we have done our introductions to all three of our types of trig graphs. So we've talked about the sine, the cosine, and the tangent. And the only changes we've really made are the period and the amplitude thus far. So today we are going to talk about some other transformations for our trig graphs, and those are for vertical shift and reflections. Now, there are additional transformations that you will learn in pre-calculus that we are not covering in the Algebra 2 curriculum. So there are more things that you can do with these graphs than just what we're looking at here. So our learning goals, some of them are the same. We want to be able to identify the amplitude, the period, and then the vertical shift of a given trig function, both when we're looking at the equation or the graph. And we want to be able to graph vertically shifted and reflected trig functions by hand. Again, we're doing all of this without a calculator. So our sine and cosine, we are now essentially going to be adding k to the end of what we started with in our 14.1 lessons. So we know what amplitude is. If you've forgotten, remember it's the distance from the midline to the max. And I should put that, how far from midline to the max and the minimum is the amplitude. The period for both sine and cosine is 2 pi over b. So the graph is going to shift either k units up or k units down, which goes with all the other vertical shifts we've done with absolute value graphs, parabolas, so on and so forth. Reflections, also very similar to what we've talked about before with absolute values and parabolas. If a is negative, if it's less than 0, then we're going to flip it. It's going to reflect, however, over the line y equals k. And this is only after any vertical shifts have been performed. So in order to graph these slightly more complicated graphs, we have kind of an order to follow, and that is, first thing you're going to do is you're going to draw a dotted line as your new midline. So previously we always started on the x-axis for the sine graphs, and then we started on up one on the y-axis for cosine. So we are now going to shift that up or down, and we will draw our vertical or our horizontal midline as dotted. Remember that this midline is going to be horizontal for sine and cosine. Then we're going to use our amplitude to count from this new midline to establish our maximum and our minimum. The rest of it is pretty much going to be the same as far as the period goes. So on these shifted graphs, I'm just drawing one full cycle. So notice I don't have anything on the left on this graph, only on the right side. So first one we are looking at, example 1, identify the important characteristics and graph the trig function. So y equals 3 sine of 4x minus 2. So we need to know the amplitude. Amplitude is a, so that's going to be 3. Period, remember period is 2 pi divided by b. So the b value is what's in front of the x, so in this case 4, so 2 pi over 4, which is pi over 2. So my period here is going to be pi over 2. Then my vertical shift is going to be how far up or down I moved, which since this is negative, it's going to be down, so down 2. And I don't know why I did this, but you need to add this in. I completely forgot to have spaces left for the domain and range, which we have done on every single one of these graphs, and we need to continue to do because it will be on the test that way. So domain for sine and cosine is always all real numbers, and the range we probably don't want to fill in until after we actually graph it. So let's look at our steps here. First, we want to draw a dotted line as our new midline. So originally we started at the x-axis. Now our new midline is going to be 2 down because that's our vertical shift. So negative 2 is going to be my new starting point because that's what my vertical shift was. So there's my new midline. Then my period is pi over 2. So that means with sine and cosine graphs, we draw the final mark as the period, and then we do halfway marks, which would be pi over 4. And then we do in-between marks, which I did not require you to label. You certainly could if you wanted to, but you do not have to. So there's our labels there, and then need some matching labels on the y-axis positive. So normally a sine graph starts at 0, 0. So because we have a vertical shift of -2, we are now starting down 2. Now the shape stays exactly the same. We start at the midline, we go up to a max, back to the midline, down to a min, back up to the midline. So I know that at every other dot, I'm coming back to the midline. So midline here, midline here. So first one's going to be the max. Now how far up do I go is my amplitude. So I'm going to go up 3 units from my midline. 1, 2, 3. So there's my maximum. My minimum, which I'm going to hit right here, I go down 3 units, and I didn't give myself quite enough room from the midline here. So down 1, 2, 3 units from the midline there. And then I connect. I didn't do a stellar job of connecting, but that's somewhat what it should look like. Notice again that this, from here to here, is the amplitude. From here to here is the period. So period is the horizontal length of one full cycle. The amplitude is the distance from the midline to the max, or from the midline to the minimum would be the same. All right, so we've got a complete graph there. Now we can fill in our range. So look at what the y values are, because the range here on sine and cosine is always a sandwich value. So the max is 1, the minimum is -3, 4, 5. So between -5 and 1 are my y values, my range. All right, let us look at B, 2 cosine pi x plus 4. So amplitude is easy, that's my A. Period, 2 pi divided by B, which is pi, so those cancel. So my period is 2. My vertical shift, it's a plus, so that's going to be up 4. I know that my domain is going to be all real numbers. My range, I'm going to have to wait until I look at the graph probably to see. So when I make my graph here, I need to start by making my new midline, which should be up 4. So 1, 2, 3, 4. Here is where my new midline would be. Then continue up. Continue down. On my x-axis, last slash mark should be the period, which is 2. Halfway is 1. And my in-betweens. So now I can make the graph. Now remember the difference between sine and cosine. Sine graphs start at 0, 0 on the midline. Cosine graphs start up at the maximum, and the second dot is on the midline. So my second dot is going to be here, and then so will this dot here because it's every other. But cosine graphs start up at the max. So from the midline, my maximum is going to be my amplitude from that midline. So the amplitude is 2, so I'm going to go 2 units up, and that is where my max should be. My min should be 2 units down from the midline. And then remember, it's not one full cycle till you get back to where you started. So right up here, I should hit that maximum again. So should have something that looks something like that. That is one full period of my cosine graph. All right, moving on. Now we're graphing a reflection. So when we are reflecting, we graph just like we normally would, but we switch the max and the min. The midline always stays the same, but the maximum and the minimum get switched. So my amplitude here is still 3 because it's always just A, absolute value, because it's a height, so it's always positive. My period, this is a sine graph, so 2 pi divided by b, which is 1, so 2 pi. My vertical shift here is none. Oops, I think I forgot. Oh, did you catch it? I forgot to do my range. Shame on me. I just remembered now. Y here was between, the max was 6, the min was 2. So sorry about that. All right, now moving on to my forgotten blanks of domain and range. So since it's a sine, I know my domain is going to be all reals. The range, again, I'll have to wait on. So this one has no vertical shift, which means my midline is the x-axis still. So I'm going to start at the x-axis. My amplitude is 3. So that means I need to be able to get up and down 3 units. My period is 2 pi, so my last tick mark should be that. Here's my halfway and my quarters. So now, on a sine graph, it always starts at the midline, and that isn't going to change. Starts at the midline. But normally after the midline, we would go up to the maximum. Now we are going to be going down to the minimum. So amplitude is 3, so 3 units away from my midline. I go down 1, 2, 3, then back up to my midline, and now the max, just 3, back to the midline. And there is our graph. I'm not going to forget to do the range this time. My range, my y values, my maximum is 3, my minimum is -3. So from -3 to 3. All right, I would love for you to try D, see if you can fill it out and graph it, and then come back to check it. So my amplitude here is 1. My period, it's cosine, so it's 2 pi divided by b, so divided by 4. So period is pi over 2. My vertical shift is 1. Because it's a cosine graph, my domain is all reals. And we'll see about my range here momentarily. So because it has a vertical shift of 1, that means I need to make a new midline dashed horizontal line up 1. My amplitude is also 1, so that means I need to make sure I go up and down at least 1. My period is pi over 2, so my last mark is pi over 2. Halfway to that is pi over 4. And then halfway's in between there as well. So this has a negative, so it is reflected. So when this one was reflected, we switched the max and min. So we're going to be doing the same thing over here. This is negative, so we're going to reflect, which means switch the max and the minimum. So cosine graphs normally start up at the maximum. So now it's going to start at the minimum. My midline is now on this dashed line. So here's a midline point and here's a midline point. The amplitude is 1, so the minimum is going to be 1 unit away, 1 unit down from that. So it's actually going to be at the origin. And then that's my minimum, and then my maximum is going to be up 1 from the midline. And then to finish the graph, I go back to the minimum. So There is your graph. Hopefully you came up with something that looks similar to that. The range we now need to fill in, the y values, the highest one is 2, the lowest one is 0. So y is between those two. All right, last one is a tangent graph. And notice that we haven't done as many tangent graphs because we focus a little more on the sine and cosine. But amplitude we've previously discussed, tangent does not have one because it extends on forever. And there is no plus minus here, so we do not have any vertical shifting here. The period is pi divided by b. So in this case, pi divided by 1, which is pi. Range is always all reals on this. So here I'm graphing a full period on each side because I've got both sides given to me. So if my period is pi, I need to get there and to negative pi. And then all I need is halfway points for the tangent graphs. So my tangent graph starts at 0, 0, and then typically it went up towards infinity at pi over 2. Well, now instead of going towards the maximum, it's going to go towards the minimum, which means there is still going to be a vertical asymptote at this first one on both sides. But now instead of starting going up, this is going to start going down, which means the other side begins by starting up. Same thing over here. This goes up, and this one goes down. So once I see that, I can come up with the domain. Remember that domain on tangents is all reals excepts. So all reals except every place where there's a vertical asymptote. So the first one is at pi over 2, and then we always do plus the period n. So the period is pi, so pi n. All reals except pi over 2 plus pi n. All right. Hopefully you've got a good idea of how to shift these up and down as well as how to reflect them. That is it for today, you chuckleheads.